Imagine for a second, you're trying to navigate a city sidewalk, but every crack, every super steep curb, every little obstacle is a huge barrier. Well, for millions of people with disabilities, that's just daily life. Our public spaces are actually legally required to be accessible for everyone, but how can a city possibly check every single sidewalk? Today, we're going to dive into some amazing technology that's finally making it possible.
I mean, just think about a city like New York. It has over 12,000 miles of sidewalks. How on earth can officials make sure every single inch is accessible? For decades, this has been a massive headache for urban planners, a real puzzle with no easy solution.
And really, the whole problem boils down to this. You've got a clash between the law and, well, logistics. The Americans with Disabilities Act, the ADA, guarantees accessibility. That's a legal right. But trying to manually inspect thousands of miles of sidewalks, that is a logistical nightmare of epic proportions. So, the ADA was passed way back in 1990, and it required cities to evaluate all their sidewalks and come up with plans to fix them. But let's be real, with tight budgets and not enough staff, that crucial first step often becomes this giant hurdle that's just too high to clear. And those accessibility plans, they end up just gathering dust for years. Think about the old way of doing this. It's painfully slow. You've got crews out there with tape measures, levels, you name it. It costs a ton of money. And because it's done by people, it's naturally prone to error. But what if? What if we could just automate the whole thing? Get near-perfect results in just a fraction of the time? Well, this is where things get really cool. This is where cutting-edge tech comes into the picture. Researchers are now using 3D laser scanners, you might know it as LiDAR, to create these incredibly detailed digital maps of our streets. It's completely changing the game for accessibility audits. So how does it work? Well, it all comes down to something called point cloud data, or PCD. Basically, a laser scanner shoots out pulses of light and measures how long they take to bounce back. It does this millions of times, capturing millions of data points. Each tiny point has an exact X, Y, and Z coordinate. So you're not getting a flat 2D picture, you're getting a super accurate 3D model of the real world. And this is what that point cloud data actually looks like. I mean, how cool is that? Each one of those tiny dots is a precise measurement. And when you put them all together, you get this incredible 3D image of the city. It might look a little abstract, sure, but you can clearly see the shapes of the buildings and the street. This is the raw material the algorithm is going to work with. Okay, so we've got this massive, and I mean massive, cloud of dots. Now what? How does a computer actually make sense of it all? How does it go from millions of points to a clear, simple answer on whether a sidewalk is accessible or not? Let's break down how it works. The whole process has 4 main stages. First, of course, the LiDAR scanner grabs all that raw data. Then comes the processing stage, where the system gets smart and filters out all the irrelevant stuff. You can think of it like digitally erasing all the trees, buildings, and cars just to get a clean look at the ground. Next, the AI classifies what's left, figuring out which part is a flat sidewalk and which is a sloped ramp. And finally, the system automatically measures all the important things, like the slope and the width, to see if they meet ADA standards. And here is a perfect visual of that processing step. On the left, you've got the raw data, right? It's cluttered with all sorts of things, poles, signs, you name it. Then, the algorithm does its magic and filters out everything that isn't the ground. And on the right, you see the result, just the road and the sidewalk. It's like a digital spring cleaning for data. So once the data is all cleaned up, the algorithm starts figuring out what's what. It analyzes the geometry of all the points and can tell the difference between a flat sidewalk, a sloped curb ramp, and the road itself. The yellow boxes you see here show how the system automatically groups these features together, basically bringing order to all that chaos. Now, this all sounds fantastic in a lab, right? But the real question is, does it actually work out there on the street? To find out, researchers from Western Michigan University took this whole system to downtown Kalamazoo to put it through a real-world test. The results were, frankly, incredible. They were clear and they were immediate. This map shows every curb ramp in the study area and it's color-coded. Green means it passed the ADA test, red means it failed. Just like that, in an instant, the city had a visual, data-driven action plan showing them exactly where they needed to make improvements. This is a total game changer for city planning. But just how accurate is this thing? I mean, really? Well, the results are kind of mind-blowing. When they compared the automated system to good old-fashioned manual measurements, the system had a mean absolute error of just 0.22%.
In other words, on average, the computer's measurements were nearly identical to the ones taken by a human. That's some serious precision.
Let's zoom in on one specific ramp to see what this looks like. The ADS says a curb ramp can't have a slope steeper than 8.33%. Okay, so as you can see here, a person went out and measured this ramp and got 10.42%. That's a clear failure. The automated system measured it at 10.60%. So not only did it correctly flag the problem, but its measurement was incredibly close to the manual one.
So, we know it works, we know it's fast, affordable, and amazingly accurate. So the next big question is, how do we scale this up? How do we use this tech to scan entire cities and bring this kind of insight to urban planners everywhere?
And the answer is to go mobile. Instead of setting up stationary scanners, the next evolution is to mount these LiDAR units on vehicles, like the Segway you see here. This lets you just drive through the city and collect data continuously, making the whole process of scanning every sidewalk network faster and more efficient than ever before.
This technology gives us a completely new lens for seeing and understanding our cities. By creating these super detailed digital twins, we can do so much more than just check for accessibility. Imagine using this to optimize everything from fixing potholes and managing traffic flow to planning urban green spaces. As we keep developing these tools, we're not just making our cities smarter, we're making them more equitable, more sustainable, and ultimately more livable for every single one of us.